Thank you very much for Professor Petrosky's inspiring talk. It's a very interesting talk. The purpose of this session is to move slightly away from the speech contents and more focused on Korean adaptive discourse. After this dialogue, we'll have a few questions from the floor. So if you have any questions, please ask just before the end of this session. Professor Petrosky's opinion and talk is very, very interesting. It's maybe paradigm for 20th centuries. But 21st century, I think it's a little bit different. Situation is a little bit different. It's strongly related to the value system. I often ask the scientists, why do you do the research? And their answer is, I want to satisfy, I'm very curious, and I want to satisfy my curiosity. Then I ask them, then why government should fund your research to satisfy your personal curiosity? And most of them, they cannot answer. Some people answer that new discovery will enhance our country's reputation through Nobel Prize. I don't know about that. I don't know. I often ask engineers, why you do the development? And their answer is, they want money. That's very simple. I like that answer because I am also an engineer. So I strongly relate it to the value, what individuals should pursue. But it is very important to make them collaborate, to make innovation happen, as Professor Petrosky said. That's especially important for the industry to align all the people to the same direction to maximize their competence. Because people, especially young people, like money in these days, I think it is very important to make them, to give them motivation for the research and development, and collaborate with each other. And there is some difference between US and other nations, R&D structure. US, I noticed that most of the government funded is focused on basic research. It's called technology push. That's very good strategy because once they have new technology, they have good infrastructure and culture and motivation to establish a company. But in Korea, we don't have that culture and infrastructure, so there is some government's role to motivate them to establish a new company. Europe is quite opposite. Most of their research topic is decided by industries through so-called strategic research agenda. So most of the research topic is defined by the industry association. Korea pushes both. Ministry of Knowledge and Economics, they drive the project based on social needs, so-called needs-based, while Ministry of Education, they emphasize on basic research, so-called technology push. It's well balanced, I think. I think Japan is the same. So that's my comments on keynote speech. And I'd like to ask how IBM think about innovation, collaboration of invention and insight. Mr. Lee, could you comment on that?
Okay, thank you, Dr. Lee. And first of all, let me thank you, Mr. Petrosky, about his inspiring speech. Listening his speech, I was quite surprised because the thinking from the professor, like Dr. Petrosky, is very much similar to the thinking of the business people, like myself, working in IBM. So IBM, for example, IBM as a business company has been thinking about how can we do a better job in terms of making the prosperity of the company. So as you know, the IBM has been a technology company for many decades, but we had a crisis in the 90s because we were so much stick to technology itself. So we tried to produce the product and solution based on technology. But that technology always didn't provide us the business results, because if that technology-based product doesn't match to the needs of the clients and customers, then there will be no businesses. So we had that lessons in mid-90s. So after that, IBM decided to apply the technology with other part of the insight. So instead of producing the product itself, we tried to combine many different ideas how to utilize technology in a more effective manner to produce the value add and to differentiate ourselves from other competitors. So I think that kind of ideas is very much similar to what you have delivered to us. Combination of technology, science and engineering together may produce better innovation. So that's very, very similar thinking. So I was very much impressed about the kind of similarity of thinking between the business community and academia. So I think this might give us a better opportunity. In Korea, we have been, many of the enterprises are thinking of how to grow the business for the next century or next decade. So whenever they are thinking of that kind of new growth initiative, they often tend to think about the one areas which they were good at it for the last 20th centuries. So one of the advice or insight that we can get from Mr. Petrosky's speech is that if we wanted to drive the innovations, to drive the additional growth or generate more value, then it might be better ideas for us to open our ideas and search for the areas to collaborate with each other. It may be the convergence of industry and convergence of technologies and the collaboration between the enterprises with the partnership, something like that. I think that kind of open innovation might be the solution for us to drive the growth for the 21st century. That's what I felt, what I learned from your speech. So thank you.
Thank you very much. I have two questions to Professor Petrosky. The first one is that there used to be many innovations from university, especially in the United States. Some examples are radar from MIT, semiconductor from Stanford, and Unix operating system from Berkeley. But as technology becomes mature and young people tend not to like science and technology, there is afraid that we may not be able to have such an innovative ideas from university. What what do you think about this, and what universities in U.S. Do, and what do you think Korean university should do? Please answer these questions.
Well, you mentioned the example of radar being developed at MIT. At the time, during that period of development, the U.S. government was funding that research to such an extent that I think it dominated all other research in the United States from the agencies involved. MIT, of course, I don't think the students there have lost interest in science and technology education. MIT is still really a flagship school in the United States, as is Stanford, for this kind of development. And I think they have the historical example, the historical models that you've cited to help with that. I think where we're finding in the United States that there isn't the interest in science and technology education is in groups that have not had models like the Stanford or the MIT. They are being recruited into science and technology education, I won't say against their will, but not because they want it. I think ultimately science and technology innovation come from individuals who have a passion for it, who are doing it not because it happens to be fashionable or being pushed by the government at the time, but by themselves. It's they who push themselves. So I think, and this is also something that's going on in the United States now, is trying to improve the image of science and technology. And I think the opening of this forum was an example that I'm going to take back to the United States, where the opening was filled with such excitement and such involvement that I think it can't help but put the audience in a mood for expecting more exciting things. I think the United States is struggling with these same questions today, so I don't know that you should look to the United States necessarily for guidance about what to do. The United States' model is one of the 19th century in large part. The manufacturing base in the United States is beyond being mature. It's in the decline in part because of what's happening in this part of the world. The United States is struggling with some of the same questions you've asked about Korea. It's struggling with how to get students interested. But as I've said, that alone will not solve our problems. There has to be an underlying passion for them.
Thank you very much. Second question is that recently our government made an announcement that will reduce CO2 emissions by 30% by 2020. Since our economy is largely based on manufacturing, there is a concern that it may weaken our economic and industrial competitiveness. But there is another view that this will stimulate innovations. Well, what is your opinion on this? And do you think this is an achievable goal and right direction?
Well, again, there are parallels. The United States, at least our president has recently announced a goal of a 17% reduction in CO2 emissions. There are the same objections that are being heard. What manufacturing base there is left in the United States is threatened in the minds of many people. Whether jobs will be created, a net creation of jobs, by this emphasis on green technology, as it's often called, remains to be seen. It will clearly displace other technologies. And so whether there will be a net gain or not is, I think, highly debatable. Now, of course, if it is something whose time has come and whose time is just dominating the agenda, the debate, then it might be something that we just have to recognize is going to come regardless of whether it's right or wrong, and there has to be, if you're an industry, I would say defensive action taken, trying to figure out either how you fit into green technology or how you can circumvent it or continue to do what you're doing in some defensive way. Whether these goals are achievable, anything is achievable. Engineers usually believe that anything is achievable, but they also know that everything has a price. And in fact, it's an oft-quoted expression of an engineer that I can do anything as long as you give me enough money to do it. And that is almost literally true. As long as you're not breaking any of the laws of nature or the laws of governments, it's just a matter of money and effort. And we know from, the Egyptian pyramids that colossal achievements were done with very low technology. It's a matter of numbers. You just keep throwing either people or time at the problem, or in this case, money.
Thank you very much. Do you have any questions either to me or Mr. Lee?
Well, I heard in the earlier part of this program that Korea has had its own economic problems, as the United States is having its own right now. What was Korea's strategy for recovering from its economic downturn?
Okay. I'm not an expert in financial area, but I do know on industrial initiatives, mostly driven by Ministry of Knowledge and Economics. There are three big initiatives: technology-driven and industry fostering-driven. The first one is Green Growth Initiative. Second one is New Growth Engine. And third one is IT-based convergence industry and technology promotion. These are three big initiatives from MKE, as far as I know. Yeah.
Yes, and those are technology-based initiatives, fundamentally.
Basically, yeah, that's right.
Mm-hmm. May I ask a question of Mr. Lee? What has been the industry's strategy for overcoming global issues such as those we faced today here in Korea? You want to use this?
Okay. I cannot say that I cannot represent whole industry, but as a company, I think each company has their own strategy to leverage the advancement of technology, because technology today is quite pervasive to the whole industry and whole society. So I think the pervasive technology, that expansion of technology to industry and society, like the company like IBM, we believe that provides a huge opportunity to create new values on top of the existing systems and processes. So as you said, the science and engineering can solve the global problems. And also the company like IBM, we also believe that we can solve the many problems that we are facing today globally, such as environmental problem and infrastructure problem, and also we can find a better way to make business decisions for the company. So we can provide new intelligence, not only confined to all the structured data, but also we can capture the real-time based data simultaneously and translate it into the business information to be used for the business judgment. So I think we called it the concept as a smarter planet. We want to find out ways to make our planet smarter than today. So in order to do that, we have to leverage all the technology coming from the IT and also telecommunication, and by combining that technology base with the new insight of the businesses. At the intersection of that technology plus the business insight, we may create huge opportunities to advance to create new way of doing businesses, new way of doing work, and new way of living. So I think that's the opportunity that we can see from the current environments, and by leveraging technology and drive the additional growth. So I think that's the IBM's point of view about how can we utilize technology for the growth of the IBM company. As you know, the IBM is very, very famous in research. We have about 3,000 researchers at Watson Lab. And they've been used to work for the developing IBM computers, how to optimize performance of the CPU and memories and input-output devices. So all the mathematicians who are very much specialized in the algorithm, they've been working in that subject to produce the better performance computer. But now they use the same knowledge and expertise of the algorithm and apply that algorithm to solve the business problem of our clients, like fraud detection in insurance company, or the optimizing the supply chain of the manufacturing company or the logistics company. So I think that idea, applying the science and the research, the output, to the business problem, may give us more opportunity to innovate and create new value from the business perspective. So.
Thank you. That's very interesting. So you're not only using technology to help business, but also business to help technology. Yes, very good. Thank you.
Mr. Lee, do you have any question to ask Professor Petrosky?
Oh, yes.
Okay. I was quite interested about your ideas about collaboration between the scientists and the engineers. But I want to know your point of view about how to expand that kind of collaboration, not only for the scientists and the engineers, but we can find out the better way of collaboration between companies and business and academia and the research institutions and even with the government. So I think in Korea we've been struggled with how to come up with that kind of systems or mechanism to collaborate with each other. We've been discussing that subject for many years, but still we don't have clear the ideas, the solution to enable better collaboration among the many constituencies. So what's your recommendation, and would you please let us share about your experience in the U.S. as well?
Well, the problem that you've just described exists in the U.S. also, how to really organize research groups, how to encourage collaboration, and to broaden the base of the group. My experience at universities, where there are a lot of research groups, for example, is that they are constantly being reorganized, and in large part because as the research group evolves its approach or its solutions to the problems that it's dealing with, it finds new problems or sub-problems, if you will. And this reveals the need for a different kind of expertise, different kind of collaborator. So it's an ongoing process. The fact of the matter is that universities also, and businesses I can't speak of, but universities often have to reorganize their research groups in response to changing patterns of funding for those research groups. So obviously the government, as being the principal provider of research funding for universities, academic institutions, can change collaboration patterns almost overnight. And that still doesn't respond to the question of how do you find the people, how do you encourage them to work together, and how do you make sure they're working together in a fruitful way. I think one answer is leadership, having the right person doing the searching, hiring, or being at least involved in the searching and hiring of new collaborators and defining what a new collaborator is. there's a famous example in the United States, and that's the nuclear reactor Navy, running submarines and aircraft carriers and other naval vessels on nuclear power. The famous head of the Naval Reactor Lab, as it was called, was an admiral named Hyman Rickover, and he personally interviewed every single person that joined that research group. And it was an autocratic system, but everybody that looks back upon it says that it worked before, it worked because he made it work, because he had the vision and he kept with it. He didn't, as he found that his system was working well, hand it over to someone else. Because inevitably that can mean that you lose all sorts of institutional memory.
I think this is very nice to hear, because the U.S. has similar problem that we have here in Korea. So I think you talked about the leadership might be a solution to enable the collaboration among many different persons, right? So many companies, especially business communities, companies want to invite and gather many ideas from many the outsiders, such as clients and partners. So the IBM has experience in utilizing the web technology to invite them to a certain subject and try to gather their ideas to innovate. So do you think that kind of online, we call it the jam, online jam session. So do you believe that kind of online, the community-based collaboration might be applied to this technology and R&D space as well?
Well, let me first say that not only do Korea and the United States share some of these problems we've been discussing today, but countries have faced these kinds of problems literally for centuries. And these are not uniquely new. I described research and development labs that started at the beginning of the 20th century, in the late 19th century. They wrestled with these same ideas about how to form a research group, how to direct it, how to focus it, and also who to hire to join it. So these are not new problems, and that's why there's a lot to be learned from historical examples in how at least to proceed. Very often we learn from historical examples mostly what did not work. Now, of course, historically they didn't have the internet, so that's a new field. And I've often been invited to talk to people in the computer IT industry because they recognize that they have no history or no deep history. So they don't have the opportunity to see cycles of success and failure as we have in the more traditional engineering disciplines such as civil and mechanical engineering, let's say. And historically things do go in cycles. And the reason they do is that when we, either individually or as corporations or as research groups, find that we're experiencing periods of success, prolonged periods of success, years or decades, we become complacent. We begin to think that, well, we've got it figured out, and we become overconfident, especially when we're confronted with a new situation that just hasn't been encountered before. And this leads to a failure. It could be catastrophic or it could be less so, but it's that failure that typically will provide the jolt to change, to make people reflect and make the necessary changes, and then goes another prolonged period of success. But it's the failure that teaches so much. The success teaches very little. What success teaches is that you can replicate that success if you do everything exactly the same. And that's very, very hard to do, and plus it's not a very fruitful way to proceed. As far as encouraging large involvement beyond the corporation, beyond the usual group of consultants, let's say, is what I mentioned in one of my last slides, and that was the idea of prizes. There are some, in the United States, the government has been offering prizes. Google has been sponsoring prizes. A lot of the big corporations are sponsoring prizes. of the order of billions, literally billions of dollars. So they define a problem, and if you solve that problem, you can be rewarded with an awful lot of money, which basically will pay for the research, or not, depending on obviously how much time and energy you've put into it. How do you determine whether somebody has solved the problem? Well, that all has to be spelled out in the definition and the issuance of the prize. But that really brings people in, and it gives them, it gives people who are not part of the circle an opportunity to do the research, at least with the hope of being rewarded for their time and energy.
Yeah, lessons learned from failure is very, very important. But to reduce that failure rate is also very important. So in that case, use IBM computer to simulate enough before you fail. That's a joke. Okay, now we have time for questions. We have time for 2 or 3 questions. If you have any questions, raise your hand and tell your name and affiliation. I hope Mike is ready near you. Okay. Is there any questions? Okay.
My name is Taishik Lee. I'm the professor of in Civil Engineering Department of Hanyang University, and I'm the member of the National Academy of Engineers in Korea. Thank you so much for your presentation, Dr. Petrosky, and all the other speakers. You were talking about 3 things, challenging and competition, and also prize. According to my knowledge, you have 2 different decades. At the period of the Edison, you are challenging to the technology of European, including the United Kingdom. And then second stage was the competition with the Second World War in Einstein time. And now it's the 21st century. Who is your competitors in 21st century? Are you competing with China or Japan? And so you have the motive you need the motive for challenge the new technology. So who is your competitor as a personal and as a nation? And second question is, we have the 3 different technologies, high technologies and middle technologies and then low technologies. But you already the shortage of the engineering student in the United States, and Korea also has the same problem. But as I know, including me, many foreigners to study in United States 1950 to the 20,000. But now many countries are developing the technologies a lot, so they want to stay just like the Japanese. So how can you solve the shortage of the engineering student and also engineers in the future? Thank you.
Well, thank you. Well, you ask who are the competitors of the United States and of individuals in the United States, and I think the Far East is the technological competitor in many ways, in all levels of technology. You mentioned that you're a professor of civil engineering. Some of the most ambitious civil engineering projects are being undertaken in this part of the world right now. Most of our rivers in the U.S. that were logical places to erect hydroelectric dams have been dammed. The places that need the long-span bridges have them. It's this part of the world that is now looking to those challenges and meeting them and coming up with some wonderful solutions. As far as the student issue is concerned, it was the case that many students from this part of the world came to the United States, especially for graduate work, and we found just, by observation that so many of them wanted to stay in the United States, and that's why we have so many on our faculties now, people from this part of the world. But that's changed now. Now with the rising technological development over here, so many of our graduate students, we find, don't want to stay in the United States. They want to come back. If they take a graduate degree in the U.S., they want to come back here, and they are doing that. And I assume you've observed this also. Many of our institutions are struggling with this problem. One way of dealing with what we refer to as foreign graduate students, obviously we have a big problem now if they are not staying and adding to our technology force. So we are trying in many ways to figure out ways to effectively draw graduate students from American bases. And there is a lot of emphasis on trying to attract minority students, underrepresented students into engineering, students that might represent first-generation college families. So these are non-traditional ways, and I think the jury is out as to whether or not that will actually work.
Is there any other question? We can have one more question. Yeah.
I'd like to ask a question to the Dr. Petrosky. I am a little bit confused because of your lecture. You named many famous researchers like von Karman and Einstein and Steinmetz, like that. And I found that you talk about science and technology and research and development, and finally you conclude that for the better collaboration between the scientist and the engineer, need a great leader. I thought that such a leader like von Karman, he was an inventor, scientist, and engineer, great engineer. Yes. But if you think about the 18th century, for example, the Michael Faraday, or go further, then you may think that Leonardo da Vinci, such a people was all, they have no division between the engineering and science actually. But nowadays we have a strong distinction between such kind of science and technology. I think that I'd like to know that the current education in science and technology could build up such kind of a great scientist or engineer to become a leader, to make a whole collaboration. If not, then what kind of education should we make? That's the question.
Yes, well, thank you. I think your observations are correct. I will only say that the examples I gave are, examples to be emulated, and therefore, in education, we should try to produce those people. As you ask, how do we do that? I think the best way to educate people is not for specifically science or engineering, although that's a sort of a necessary thing because that's the way our institutions are structured, but to educate them so that they know how to learn and be inquisitive on their own. Ultimately, people graduate from an institution, they take a degree with them, and then they're on their own, or they can be on their own. They have to know how to learn on their own when they're not taught anymore. And as most people eventually learn, you can teach yourself pretty much any subject if you put your mind to it. So those who graduate as scientists can learn to be engineers. They don't need education to help them do that. They just have to do it on their own. They educate themselves, if you will, and vice versa. And I tried to indicate that that actually does happen in a much greater way than we think. When I gave some numbers about the membership in the U.S. National Academy of Engineering, it's very desirable for engineers to be elected to that. And yet a large portion of those elected to it are actually scientists by education. But by practice, they are doing engineering work and so could actually be called engineers. At a certain level, and the level like of Faraday that you mentioned, the distinctions disappear. And I think that can still happen today. And I think the educational system is probably not going to be affecting that for brilliant individuals one way or the other.
Okay, thank you very much. Now we are in a position to close this session, very interesting session. We appreciate the experience and insight by Professor Petrowski based on his U.S. history. This certainly inspired all of us in this room. The core competence of an individual and enterprise and country is the ability to create value, I think. The question is how to find what people want and how to provide them through collaboration among many people in diversified fields such as technology, science, and art and sociology, even philosophy. I think that's the core competence in this time, as President of KAIST said. Okay. Thank you very much. Close this session. Thank you very much.